My name is John Tkaczewski. I'm the president and co-founder of FileCatalyst. I have been doing webinars for the last almost 2.5, 3 years. I have several topics. So if you go to our website on the past webinars link there, you can see several new topics. I notice in this webinar there's a lot of you that are new to FileCatalyst. So I'm gonna try to give some basics first about TCP and versus UDP. However, if you wish, you can just skip forward. If you're watching a recording of this, you can skip forward to the part where I'm actually talking about the advanced features, UDP features in FileCatalyst. And I also invite you to go visit our blog regularly. We write at least 2-3 times a month about topics like cloud, software development, file transfer, of course, etc. So FileCatalyst is a file transfer tool that allows anyone to transfer files at full link speed. Other protocols, which I'm going to get into in my next slides, can only partially fill the link, and therefore you never can get your full bandwidth that you're paying for, and the file transfers are actually much slower than what your link is capable of. So what we can do here is transfer files at full line speed. This is really built for bulk data transfer of very large files. We're integrated with all the major cloud storage vendors such as Amazon S3, Windows Azure, OpenStack, etc. So this allows you to do it, to transfer files to those. And we are very much a multi-core architecture. So when you're, for example, transferring files, we can do it on one core, and encryption, decryption, for example, will be happening on a different core. This will give you a much better speed improvement, especially when you're dealing with large systems. So what's the issue with TCP? FileCatalyst wouldn't really exist as a product if TCP was all perfect. The biggest problem with TCP is that it falters on, it starts to slow down as soon as you introduce latency to the network. So latency is a product of speed of light going only a certain speed. So if you, for example, want to shoot a beam of light around the world, if you, let's say, could curve it, that beam of light would take 2 seconds to go around Earth, and that's your delay. That's really your delay. Similarly to satellite links, when you're watching TV and a reporter on the other end of the world has to wait for the question to arrive to them, and they're just standing there nodding their head and waiting for the full question to arrive. So really, that's what it is. The TCP is much of a linear process, meaning that you take a bit of data, you send it over the wire here, and you wait for the acknowledgement, and then the next set of data is sent. So it's a very serial process. That's why you cannot never fill out the pipe, because there's only very limited amount of data that can go on the wire, and on top of this you have to wait for the acknowledgements. With FileCatalyst, why are we faster? Well, first of all, we're sending a lot of data through that line. So there's not just one little packet of data, there's several packets of data going through at the same time. But at the same time, we're also only acknowledging problems or exceptions. So when we're sending data, we don't wait for an acknowledgement for every single packet. We just send the next one, and the receiver will raise their hand and tell us if there was a problem of sending files. Of course, any kind of bandwidth maximization protocols have to have a very adaptable congestion control. So you don't flood the links. When you're transferring files, you want other applications still to be able to do things. And that's why you have that ability to slow down and speed up dynamically when the files are being transferred. Another thing that this is really good for is to specify the exact rates of transfer. So especially when you're working at very large systems where you can have, let's say, hundreds or even thousands of these file transfers, UDP will allow you to control very, very precisely at the rate you're going so you can manage your resources better. And this is something important as well for the larger systems. And because you always know you're going to get a full link speed, you get a predictable result. So if you're transferring a file from here to Rio, for example, you'll always get a good speed. So what does it really mean? So with TCP, we can send, a few packets at a time. What it really boils down to is this information here, RTT, or round trip time, between the two locations. So here's an example, LA to New York, where you have a delay of 70 milliseconds. This is roughly how long a packet of data takes to go from LA to New York and back. And when you're transferring a file with FTP, it takes, over 5 hours to send a 10 gig file. With FileCatalyst, this will take a minute 24. Once again, because we're maximizing the throughput. So with FTP, you're using a fraction of that gigabit line, and with FileCatalyst, you're using a full bandwidth. Now, if you look at the speed here on for 130 milliseconds LA to Rio, once again, the RTT increases, FTP gets affected, we stay the same. What's interesting is that if you put two computers side by side, so there will be no latency, then FTP will also take a minute 24. So this is an interesting factor that, as long as you're not going far with your transfers, the acceleration becomes less important. You have to be going, coast to coast, or within, if you're within a large country and you have a long distance, long haul networks, this is very important. If you're transferring files internationally, this is also very important. So let's go through some basics here. So first, what I'm going to show you, I don't want to really spend too much time on the PowerPoint, but this is all I have for PowerPoint for now. So I have here Filezilla. I created a server here. I'm connected to a server which has a bit of a delay to it. The delay is, I'm just going to use a ping here to test it. 207. Oh, and I think ping is disabled here. But I'm using an emulator here to connect to this server. The emulator is turned on here. You can see I have 80 milliseconds of latency on one way and 80 milliseconds the other way, and I have a very minimal packet loss. On the internet, the packet loss, I think, is under 1%. I think it's an average of 1/4%. So this is a little bit, better than what internet would provide me. But this is the delay I'm looking at. I'm emulating. So let's start with the first simplest file transfer. I'll take one big file. I have a file here of 600 megs, and I want to move it using Filezilla. So I start the transfer, and here's what I'm seeing is that this transfer is going to take roughly 6.5 minutes. You can see here the ETA in Filezilla. It's one file at a time because I have only a single file to transfer, and this is going to go on for 6 minutes to transfer this file through to this server with 160 milliseconds delay. So I'm going to stop this now because this is going to take way too long, and I'm going to use FileCatalyst for the same type of transfer. So we have several different client applications. For this demo, I'm using HotFolder, which is an automation client, but it also allows me to kind of set up my tasks. So when I'm showing you different demos, I don't have to always reconfigure everything from scratch. I already have a specific demo set up. So I want to show you here a single big file. So it's uploading the same file again that I just did in Filezilla. And here's the same file transfer going on with FileCatalyst. So as you can see, the transfer speed is much better. You're looking here at, sub probably about 25 seconds to transfer this file versus 6 minutes, which is a great improvement. You can see bandwidth usage here was above 400 megabits. I had my link set up to 400 megabits, and that's what I have pretty much achieved here with this transfer speed. So this is the simplest file transfer. Any file transfer accelerator, UDP based accelerator, would be able to do this. And shaving off 5.5 minutes of a 6-minute transfer, this is nothing new, and everybody has you have seen this if you have looked at any UDP acceleration. What I wanted to really talk about here, it's as you can see here is my example 600 meg file and 160 milliseconds delay, and it's 6 minutes with Filezilla, and plain UDP with checksum. I call it plain UDP because it's just a single stream of UDP. It takes 24 seconds. So let's go into a more complex transfer. So now let's see what happens if I want to transfer a bigger file set. So I have a file set here of 47 files. As you can see, I have 261 megs to transfer these files. So first thing that will come to your mind, well, if I have this acceleration, all I have to do is just create a zip file and send the zip file over. And this is my second point, is that yes, you can use compression, but that actually creates some other headaches. Well, first of all, you have to compress your data set. So this is a benchmark I actually found on zip archiving. You can see that compressing 137 megs with zip takes about 45 seconds. Plus you need the disk space now, because now this will get compressed, let's say, by 50% or so. So you end up needing like 60 megs on your disk to transfer it. So you have to wait for the compression, and you need the disk space to move the data. If you're moving small sets, yeah, sure, this will work. However, if you're starting to get into gigabytes and terabytes, this idea of just compressing into an archive and sending via acceleration might not work as well. And I'll show you some examples of that. So I'm going to now transfer using Filezilla again, just to give you a comparative. I'm going to send a big file set, which is those 47 files, just to give you, let's set up here some kind of benchmark so we know what we're looking at. So Filezilla is going here, sending the 47 files. As you can see, they're going pretty quickly, but there's 47 of them. You can see that there's some kind of parallelism here, and what I mean is that there's two files at the same time going through Filezilla, which will give you some acceleration because you're doing two files at the same time. And I downloaded a little stopwatch application here, which I didn't start at the right time, to kind of time this out, this transfer. So this transfer is going to take roughly 2 minutes, just over 2 minutes, 2 minutes and 15 seconds. And I'm not going to I don't want to sit here and watch Filezilla transferring. This is not why you signed up for the webinar, but it gives you an idea that how Filezilla deals with this type of transfer. So I'm going to just cancel this now. And then if I do 5 here, there we go. So here are my files. Let me just delete this. So I clean up my remote files on the server. So now let's see what I can do with this file set using FileCatalyst. So I'm going to open up FileCatalyst, and I'm going to do a simple upload with just UDP of the same data set. So 47 files, and I'm going to, even to make it identical, I'm going to disable verify file integrity. So this is an MD5 checksum. So after a file is transferred, we'll do an MD5 checksum on the file sent and received. And once again, this is an operation that takes time, so I'm going to disable it just to have it comparative to Filezilla. Filezilla doesn't do an MD5 checksum. So I want to have a comparative here. So I'm going to do just UDP upload here. So I'm just going to start a transfer here. And so let's see here what happens with just a plain UDP transfer. So as you can see, I'm transferring these files. Um, it's a bit faster than Filezilla. How much faster? Well, I'm giving here an ETA of about 1:40. So instead of 2 minutes and 10 seconds or 2 minutes 15 seconds that Filezilla was taking, I'm doing this now roughly 35-40% faster, which is, not amazing, but it is faster. And to be honest, once again, I want to stress the point that every single UDP accelerator on the market would be able to do something very similar in speed. And I am not here really to show that I can do UDP transfers of 47 files. That's not my point. But I just wanted to stress the point that if I do a regular transfer here with FileCatalyst hot folder, sequential transfers, you can see I can do this, maybe 40% faster than Filezilla. And I think we're finished. Yeah, there you go. We finished. It took I think it took less than 1:30 to do it. So now we're going to do something more interesting with this. So in FileCatalyst, we have a concept of called multi-client. So if you go to multi-client option here, you can enable. You can say how many connections you want all at once. So here I'm saying that I want to do this file set with 5 concurrent connections. And I want to do an MD5 checksum. So now I'm actually going to be not only transferring, but I'm going to do an MD5 checksum on this transfer. So I'm going to execute this transfer here just to show you how this goes. So I'm doing a multi-client. That means 5 files are being sent at a given time. You can see here that there's 5 of worker threads working on it and transferring this. And you can see right away, because I have now more files working at the same time, my speed improvement is quite considerable. I'm now going in probably under a minute for this transfer of this data set. And once again, I haven't really used compression here. It's the same files. All these files are already compressed. They're sitting on the disk. I'm not archiving. I'm not doing anything. I'm just transferring from one place to another. I didn't have to wait for any zipping. I didn't have to allocate more space. But as you can see, this took about 30 seconds to transfer with the multi-client option. All right, so now we had a multi-client. So now we're going to add another concept to this. We're going to add something called zip chunking. So I'm going to edit this task just to show you the settings. So again, I have my UDP. MD5 checksums again is turned on, which once again, this adds overhead. I'm not talking here about this overhead. I'm just doing it. But I enabled here a single archive transfer. So when I'm transferring files, everything gets zipped up on the fly to like a zip stream, and then the zip stream gets transferred over to the other side, to the sender. And let's see what kind of speeds we can get with this. So now I'm transferring this file. I'm transferring as well with a temporary file name just to make things a little bit more interesting, so I know that if a file is in transit, it shows. And it took about, I don't know if it took 20 seconds. I forgot to start my little timer, but you can see this, it's done. So you can see how much faster it is now. So I went from a transfer that was taking over 2 minutes with Filezilla, or 2.5 minutes. With plain UDP, I got it down to 1:30, 1:40. And now I got this transfer. Then I tried with just multi-client, which is not a single archive idea, and I got it down to about a minute. And now I got it down to about 45 seconds. And final option I have here is something called multi-client with compression. and this option here, let me show you what I did. I enabled again MD5, enable multi-client with 5 clients, enable auto archiving of small files. So this is a very interesting because will let larger files go on its own, and the smaller files will get compressed into smaller archive. At the same time, I enabled compression, and I left it at fastest so I don't spend too much time on the disk because this data is already compressed. I'm really just using this to get a little bit faster processing on the files. And if I transfer with this, it has to build up the stream. It takes a little bit of time, but as you can see, we're 5 seconds into this right now, 7. Oh, it took about 10 seconds, I think, to do that transfer. So I just went from 2 minutes 15 down to 1:40 with plain UDP, down to a minute with just using multi-client, down to 40 seconds, and now down to about 10 seconds to transfer the same file set over the line. So that's really what I wanted to show. It's all these advanced features. So you have several features here in FileCatalyst that you can set. Bottom line is you have to know a bit of your data set. If you're transferring only very big single files, then single UDP is probably going to work fine for you. If you're doing kind of mixed data sets like I'm doing here in my demo, well, then you can see enabling multi-client, enabling single archive compression, enabling auto-archiving into small files. These are all features that we have built into our product so you can get your files as fast as possible and really, really trim down the transfer time down from, several, 10 or 100 times fold. So what does this mean at the end here? So I compiled here a little table for you. So here you have Filezilla transfer of this file set, took 2 minutes and 10 seconds. Plain UDP took 1:20. Plain UDP with checksum, that means we're going to do a bit-by-bit comparison, took 1:40. And now I'm getting into these advanced features, the what I call features unique to FileCatalyst, so multi-client. Your single archive with checksum, your multi-client with checksum and zip compression. And you can see how this goes down. So if you're looking around for acceleration, I mean, there's open source acceleration, there's competing products, but not all of them will be able to give you that additional speed that you can get with our product. So what are the other options? Well, there's some other things we can do as well to help you up with speeding. First of all is rsync. So let me show you here a file. So I have a file here. It's a 50 meg file. I'm going to transfer it now with Delta. So what did I change here on this one? Everything almost is the same. The option I changed here is called file deltas. So what it means is that when a file has changed, we're only going to send the bytes that change. We're not going to send the entire file all over again. And I was trying to illustrate it as quickly as possible. So this is what I did for this. So I'm going to do my initial transfer of this file. And I'm done. So I transferred this 50 meg file, and now I'm going to open up this file. I'm just using my Notepad++ here, but you can use whatever you want. And I'm just going to add some stuff to it. Test, test, test. There we go. Just make it a bit bigger. Save it. And now I'm going to run again the same task. And you can see here in the logs, it will show you that it's actually so that the file incremental upload It noticed the file, it built the signature, it transferred the signature, it transferred the FC6 file, and that's it. And you can see that the bandwidth was there's not even a blip on my graph because it didn't use any data. It really just, well, it used a bit of data. It was just for that little few changes. So where's this good for? This is really good for those that are on satellite links where you have to pay for every kilobyte you send via satellite. This will lower the consumption of bandwidth. Another new more recent application is cloud. Most cloud vendors will not charge you to bring data into their cloud. So if you want to upload data to a cloud, it's free. However, you want to pull data from the cloud, now you have to pay, and sometimes you have to pay big bucks. If you're, for example, uploading some data, you're going to do some processing on it, and then you're going to pull down this data from the cloud. Well, if you're using this idea of an rsync, well, you're going to pay a lot less in the bandwidth move because you're only going to be moving the deltas every time you make a change. So once again, this works on video files, it works on database files, it works on a number of applications. Some other things we can do. I'm not going to really just go briefly into it. We have something called directory streaming. So directory streaming meaning, let's say you have an N file problem. So you want to send 7 million files that are in a folder. Well, you know how if just browsing into opening up Windows Explorer and opening a folder with 7 million files, it will probably crash your Windows. So it's a big problem of sending N files, what we call N files, meaning N being infinity. So we have the ability to do directory streaming if you want to send very, very big data sets. And finally, we have also file system events. So if we're, for example, have to keep in sync a folder that has several 100,000 files, instead of scanning that directory every time to find new files to transfer, we'll register file system events, and only if a file changes within that folder, we'll transfer it. Once again, there's some limitations to it. It has to work on a local drive, or it has to be an enterprise level storage. Regular like Linux Samba Share, for example, will not give us file system events. So there's a little bit of work there to be done, but it's another way to speed things up. So that's it. Thank you very much. I'm also recording this, so I'm going to stop my recording now, and if you have any questions, I will be happy to answer them.